Hello, calculus students. We are doing optimization problems in section 4.6. So it's the last one on this page. And let's take a look. It says, after an antibiotic tablet is taken, the concentration of antibiotic in the bloodstream is modeled by this function, C of t 5 parenthesis e to the negative 0.4 t minus e to the negative 0.6 t. So somebody studied these and have come up with functions. Where the time t is measured in hours and c is measured in, that stands for micrograms per milliliter. So they're measuring the amount of antibiotic in the blood system, most likely, probably milliliters of plasma. Now, I got this problem from somewhere and it didn't indicate exactly milliliters of what, so we'll just give that as the unit. Find the maximum concentration of the antibiotic during the first 12 hours and give the time at which this occurs. Sketch the graph, and I'm giving you the x, the window. This is the x-axis and this is the y-axis. Label the axes with correct units. All right, similar to the one before it, and it's nice to have the function given to us, right? So the first problems up here, 1 through 4, we always had that primary equation and the secondary equation, but these last two, we were given the functions, and we were now asked to find, what are we asked to find here? Maximum. So we're trying to find the maximum concentration, and there's our function. C of t is equal to 5 e to the negative 0.4 t minus e to the negative 0.6 t. T is in hours, c is in micrograms per milliliter. We're going to take the derivative. I'm just going to leave that 5 out there. And the derivative of this is itself times the negative 0.4. So I just put the negative 0.4 e to the negative 0.4 t. It just stays the same. And then when I take the negative 0.6 times the negative, I get a 0.6 e to the negative 0.6 t. Set that equal to 0. Now, these are never, you have to think a little bit. Let's see. I think I told you to factor out the smallest one the last time. I think you just factor one of them out. One of what? The e to the negative point, either factor e to the negative 0.4 t out or e to the negative 0.6 t out, because that'll get rid of one of these and give you a nice factor here. So I've got my 5. I took out this one. All right, let's see what happens when I do that. So if I take that out, it's missing here now. Plus, now you know that negative 0.4 plus negative 0.2 gives you the negative 0.6. So I think it's easier just to take out this one instead of this one. That is easier to see. Okay, now I set these equal to 0. This one we've talked about is never 0. So I'm going to take negative 0.4 plus 0.6 e to the negative 0.2 t. Set that equal to 0. Now what I did was I added 0.4 and I divided by 0.6 and I end up with 2/3 on the right hand side. You can pause this and make sure you get that. Now to get this, to get something out of an exponent, you're going to need logs. Yeah, note to self, if you need to get a variable out of an exponent, you need to use logs. So I'm using natural log because of this e. So I take the natural log of both sides. Okay, and when you do that, the ln and the e, these functions are inverses of each other. So they sort of undo each other, and I'm left with negative 0.2 t equals ln of 2/3. Now divide by negative 0.2, put that in the calculator, and get 2.03. So about 2. So, and then I put c of 2.03 and I got 0.74. I just put that right back into the original function. And so I say to maximize concentration of the antibiotic, let me read my writing again. The maximum concentration of the antibiotic is, it's the y value. You know, this is your x and this is your y. Really, that's your t here. And this right here is your c, the concentration. And remember, the time is in hours, right? That was way up here. T is in hours, C is in this micrograms per milliliter. Okay. So I'm going to write the maximum concentration of the antibiotic is 0.74 micrograms per milliliter And then I was going to say at, but I just put 2.03 hours after the tablet was taken. All right, and then I graphed it. I used the calculator totally. It says for the first 12 hours, so I'm going to graph it for the first 12 hours. And on this axis, like I told you here, to graph, go 0 to 12 by 2s and 0 to 0.8 by 0.1. So 0 to 12 by 2, 4, 6, 8, and then 0 to 0.8 by 0.1s. So that gives you 0.1, 0.2, 0.3, and so on. Now label, this is hours, and this is micrograms per milliliter, and you'll see in your calculator that that is what you have. Let me see if I still have this in here. I do. Look at that. How lucky was that? You can also check that maximum by going second, calc, and then go down to this maximum. You can always check your work. And you go to the left of that. So I am going to maybe put in a 1, enter, and then go something over here, maybe a 6, enter. And it's saying, is your maximum in between here? And you hit enter, and voila. Notice that it is 2.03 and 0.74. So on your calculator, and remember, we're putting in the original function here, and that is how I got my answers. Actually, validated or verified. Notice I didn't use the calculator at all here as far as graphing. I waited to the end to verify my calculus, which is why the directions always say, use calculus to solve the following problems. All right, that takes care of our optimization worksheet.